the normal distribution. Example 3. Now Z represents a special case of a normal distribution, and it's where the mean is 0, the variance is 1. If we square root 1 we get 1, so the standard deviation is equal to 1. And if we do a sketch of this normal distribution, we have to put the mean in the center and then a usable scale along here would have 3 standard deviations in each direction. So if we have 0, then we add a standard deviation, so that would be 1, add 1 again, so that's 2, that's 3. On the other side we would have -1, -2, -3, like this. And there's nothing wrong with negative values for a random variable. For example, temperature, which is a continuous random variable, can take negative values. So there's nothing wrong with negative values here. Okay, so what's the probability that Z equals 2, that our random variable takes this value? Well, we already know that equals in any continuous probability distribution, for example the normal distribution, gives you a probability of 0 because nothing's shaded. If it was less than 2 or greater than 2, you shade something on the sketch here, less than 2 or more than 2. But equals to 2, we're not shading anything. We just have this. PZ greater than 2. So we need normal calculations, and we're going to use the cumulative normal distribution, that's option 2. Now the lower value is 2, so we're looking for this region here, and we know this region doesn't stop under 3 as it might appear on the sketch, it goes to infinity. So lower value 2. The upper value, we need something that goes way outside the distribution, so maybe something like 10 for instance, and the mean is 0, so 0.0228 to 3 significant figures. So for the probability that Z is less than 4, I've had to extend my distribution, and we can see the area shaded is pretty much all of the distribution. The answer is going to be almost 1. So the lower value there, if I pick something out at this end, for example -10, the upper value will be 4, the standard deviation is 1, the mean is 0, and we can see we have a probability that's almost 1. And part E, the probability that Z is less than -3.99, so we're at this end. Less than means we're shading to the left, and we can't really see much to shade to the left here. The probability is almost 0. So the lower limit, so I'll stick with the -10. The upper limit -3.99. Standard deviation 1, mean 0. 3.3 times 10 to the power of -5 in standard form, and in ordinary form it's this value here, which is almost 0.